God rocks.
Hello, everyone, and welcome to a brief history of climate changes through geologic time. This is an interactive edition, so as we move along, try to give your best answer to the questions that pop up. You may be surprised to realize that, you know more about climate change than you think. First, let's start off with the definition. What is climate change? Can anyone offer a definition? Climate change refers to the long-term shifts in temperature and weather patterns. This can apply to specific zones on the Earth, like tropical climates in tropical zones, and it can apply to the globe as a whole, like global climate change. Now that we know what climate change is, what kind of factors impact climate? Yes, atmospheric gases impact climate. Our atmosphere is made up of many different types of gases. Can you name some gases that make up our atmosphere? Yes, we have lots of oxygen and nitrogen. We also have ones that are called greenhouse gases. They are a special group of gases that are important to our atmosphere. They are responsible for a special phenomena called the greenhouse effect. Raise your hand if you have ever heard of the greenhouse effect before. The greenhouse effect is when these special gases trap some of the heat from our sun in our atmosphere. It turns our atmosphere into a warm blanket that lays over the earth, making it nice and comfortable for life on earth to grow and thrive. Surface reflectance is also another factor that impacts climate. The refraction of light reflected from the surface of the Earth is what scientists call albedo. We can measure albedo by looking at what shades reflect more light. Like here, we can see that the lighter shade reflects more sunlight than the darker shade. Which shades do you think absorb more heat? The darker shade that reflects less, or the lighter shade that reflects more sunlight? Yes, the darker shade absorbs more heat because it reflects less sunlight. So when we look at a map of the Earth, we can see the Earth has many different shades on it. The Earth has darker shades like the oceans, forests, paved roads. All of these absorb more heat because they're darker shades. This makes the Earth hotter versus the lighter shades on the Earth, like the ice at the polar caps and deserts. These reflect more sunlight, making the Earth cooler. This is called the albedo effect. There are other factors that also impact climate change, and they come from outer space, like orbital mechanics, meaning the tilt of the Earth, its wobble, and even its orbital shape. You see, the Earth doesn't actually orbit the Sun in a perfect circle, nor does it spin straight up on a perfect axis. These small deviations have a big impact on the Earth's climate over time. What if I told you that meteors can also affect the Earth's climate? Can you think of a time where a cosmic event like a meteorite affected the Earth's climate? Hmm. Aha! The Cretaceous extinction. This is the meteor that caused the extinction of the dinosaurs 65 million years ago. So, what we've learned so far is that the Earth is dynamic, since there are many factors that impact climate on Earth. Do you know the age of the Earth? Like, how long have these climatic events influenced climate on Earth? What do you think? The Earth is 4.5 billion years old. That is a long time. In all that time, how many climate changes do you think the Earth has actually had? Well, the answer is many. Hmm, let's get a good understanding of how old the Earth actually is. We know 4.5 billion years is a long time, but how long exactly? This bag here on the right represents 1 million years, and this on the left represents 1 billion years. In other words, we need 1,000 of these 1 million years just to make 1 billion. That is a huge difference. 1 billion is so much larger than just 1 million. Now imagine this times 4.5 for the total age of the Earth. Wow, the Earth is super old. Let's put those 4.5 billion years into context. If the Earth was a football field and we zoom in to this last section at the end, and then we zoom in some more, and we look at the last two lines on the football field, right here is where the dinosaurs first came into existence ever. And this mark is where they went extinct from the meteor that we just talked about earlier. And this last line here is all of human history. We're talking Neanderthals, ancient Egypt, ancient Rome, and even today. So out of this entire football field, all of human history is tied up in this last final line. Now, if we divide up that football field into different categories, it would look like this. But we know the history of the Earth isn't actually a football field, right? Instead, scientists show the Earth's history as groups of different categories called periods. Each category represents a unique environment in Earth's history. Here is the beginning of time on Earth at about 4.5 billion years in the past, and the dinosaur extinction happened about 65 million years ago here in the Cretaceous period. And human beings live here today in the Holocene period. Let's go back in time and take a look at what the climate was like during some of these different periods on Earth. In the past, Earth has had some chilly times. Some of these events were so cold that scientists refer to them as snowball Earth. What is a different name for a very cold climate on Earth that lasts a long time? Exactly, an ice age. Ice ages are more than just long winters. They can last millions of years. Ice ages happen when average global temperatures drop and large swaths of land are covered by glaciers. So, how many ice ages do you think the Earth has had in its past? Give it a guess. The Earth has had not one, not two, not three, and not even four, but five major ice ages in the past. Now, the Earth has also had some super warm periods as well, and we can understand this as greenhouse Earth. During the Carboniferous period, Earth was on average a lot hotter and more humid than it is now. Have you ever seen movies or depictions of prehistoric Earth where there were really big bugs? I'm talking massive centipedes crawling on the forest floor and dragonflies almost the size of birds. Have you ever seen depictions like this? That is because during the Carboniferous period, the Earth had more oxygen in the atmosphere than it does right now. The atmosphere back then was about 30% oxygen, and today we breathe an atmosphere that's only about 21% oxygen. For greenhouse Earth, we can also look at the Permian period, where the environment was more tropical and dry. During this period, the greatest mass extinction event to ever take place occurred. In fact, this mass extinction was so significant that it's referred to as the Great Dying in the geologic record. So, if the environments of the past varied so much due to different climates, then what's the deal today? Let's take a look. What do we know about climate change? Can you name some facts that we know about climate change today? Think about the different factors that impact climate that we mentioned earlier. We have rising greenhouse gas emissions, which increase the greenhouse effect, making the Earth warmer, causing melting ice. We can see here that over time, there's an increase in carbon dioxide in the atmosphere. We also have a decrease in that surface albedo that we talked about earlier. As the shiny ice melts away, surface albedo goes down. This causes sea levels to rise as that shiny ice melts away. If we look at this map, it shows us the North Pole relative to the South Pole, and you can see in the red the decrease in surface reflectance, that decrease in reflecting sunlight. But hang on, hasn't the Earth's climate always changed? Well, yes, it has. In fact, the Earth has cycles and patterns of climate changes. These cycles of ice ages are a good example of this. Over time, the Earth has had many ice ages, like we talked about earlier, and they happened in cycles. So, if the Earth's climate has always been changing, then what exactly is the issue with climate change today? Well, it all comes down to this one tiny detail: the rate of change. The natural climate changes in Earth's history occurred over long timescales. We're talking hundreds of thousands or even millions of years. Earth's climate has been relatively stable for the last 10,000 years, up until this sharp change at present. The magnitude of this change is quite significant. And if we look at this time scale, this large change has happened in such a short amount of time. So the problem isn't necessarily the change in Earth's climate. Rather, it's that the change is happening so quickly. This plot of temperature data shows how quickly the temperature is changing using data from just the last 30 years. The red represents a positive change of 1 degree Fahrenheit per decade. And we can see over the north section of the Earth, we have the most positive change in 1 degree Fahrenheit. So now the question is, what is causing this fast-paced climate change? Is it natural or is it human caused? When we look at relationships between human emissions and atmospheric carbon dioxide, we start to see an uncanny resemblance. The overwhelming consensus is that yes, climate change is human caused right now. Our lifestyle and behaviors, our emissions, trend extremely well with climate data. How far back in time do you think we need to go to reach the same level of carbon dioxide emissions in the past as we have today? Give it a guess. The answer is 2.5 million years in the past. That's how far back we need to go. All the effects of climate change that we see around us today are caused by a current global average temperature increase of just 1.18 degrees Celsius. Now that we know exactly what the problem is and where it stems from, what do we see when we look ahead? We know we cannot just shut down society and stop emitting greenhouse gases tomorrow. So, with this in mind, different plans of action, different scenarios have been proposed. And with each plan comes a projection into the future of what the relative change in temperature increase would be under the projections of each plan of action here in a different color. What do you think the global goal is right now that we should limit our warming to? If you take a look at the plot, here's a hint. It's in blue. The answer is 1.5 degrees Celsius. Under this light blue projection into the future, we can see under this plan, we would limit warming to about 1.5 degrees Celsius. If we want to be giving sustainability and serving Earth coolness, we need to understand that the types of changes that are involved in the projections mentioned earlier to reduce our carbon output look like finding sustainable energy resources. And a big one is adopting nuclear and hydro energy here in Canada. We need to focus our energy on creating greenhouse gas sinks, generating environments and materials that remove greenhouse gases from the atmosphere, like forests and soils. Lastly, we need to focus on lifestyle modification. This means improving infrastructure for habits like composting and waste reduction. Beyond all of the scientific projections, what can we actually do at home? The best thing we can do is to be a good global citizen and adopt a more sustainable lifestyle. This looks like shopping locally instead of shipping everything straight to our doors. It looks like reducing the amount of packaging that we consume and also avoiding single-use products wherever possible. I know that we all love Amazon Prime shipping and plastic Starbucks cups because it's convenient. However, when we look into the future, what is the most convenient is to have a stable and predictable environment long into our futures. Thank you for listening and engaging. I hope you learned something new here, and happy Earth Day.